Okay, so now I'm just going to go over more of these examples. Now, some of these examples I'm truly stumped, but I have a computer open in front of me and I'm just going to Google factor. I could Google factor 110, and what we see, right, 110 really is 10 times 11. Now 11 is a prime number. 10 is composite, so I need to break up 10 some more into its factors. So what two factors exist since 10 is even? For sure it has a factor of 2, but also 5. So 2 times 5 times 11 is 110. So that's the prime factorization of that. 21. Well, 21, that's fair enough. So I know that 21 has a factor of 3 of it. Why is that? Because the sum of its digits is equal to 3. And the divisibility rule for 3 is if the sum of all the digits is divisible by 3, then the number itself is divisible by 3. Well, and it should be no secret, 3 times what gives you 21? Well, 3 times 7 gives you 21. Now, this is cheeky. This number is absolutely gross. Factor. Now, this number is very, very tough to factor. And in fact, the prime factorization of this is 13 and 17. Now, that doesn't seem very fun. How would you know that 13 is a factor? The only way is through division. On the other hand, 30. Well, the sum, I'm going to maybe break it up like this. 30, what two quantities multiplied together give you 30? 5 times 6. That's how I would break it up. Wouldn't you know it? 5 is prime. 6 is composite. So I'm going to break it up into its prime factors. Since 6 is even, I know that 2 is a factor. 2 times what is 6? 3. So the prime factorization of 30, I can write as 2 times 3 times 5. Now, why is this so important, writing in the prime factorization? Number one, it gives a unique descriptor of all the factors of a number. And it'll also help out when we go deep into this unit here. So I'm going to type in factor 176,111. So, by the way, are any even numbers a factor of this? No, there are no even numbers, simply because the number itself is odd. All right? Let's go even further with this. How about 3? Nope, 3 is not. If you add up those digits, all those digits add up to 17. Since 17 is not divisible by 3, this 3 is not a factor. 5 is not a factor. 7, I don't know. I just tried dividing it. Doesn't divide by 7, so 7 is not a factor. 9, if I add up all of those digits add up to 17. 17 is not divisible by 9. Therefore, 176,111 is not divisible by 9. 11? No. 13? Yes. Oh, this is just incredible, this. Now, the prime factorization of this number is, I'll have to type this in. Prime factorization, thankfully we have computers to figure this out. The prime factorization of this number is 13 times 19 times 23 times 31. Now, that is not a nice prime factorization. Hopefully things get better. All right, moving on. On our own. So 2,646. So I am going to do this example, and this is kind of beastie. It is very, very nasty business what I got going here. So just for fun, like I could take out 2 as a factor, but if I do that, I'm left with some really, really big number, like 1,323, right? I guess I could do that. I've started this up already. But now I'm left with another problem. 1,323. Well, what's a factor of this? Well, you know what? Just for fun, over here, I am just going to add the digits. And if I add the digits, does that tell me anything? 1 plus 3 plus 2 plus 3. So that's 6, 8, 9. In fact, this adds up to 9. So that means that 9 is a factor. So what I'm going to do is I'm just going to say, I know that this should not be prime, by the way. This will split up into 9. 9 times what gives me that? I don't know. You know, sometimes there's easy ways to do things in math. This is not one of them. This is really nasty business. Yikes. 9 times 147. So I'm going to split up 9 into its prime factors, and that's good because that's 3 times 3. Now 147, what is so special about 147? I have actually no idea what's so special about 147. And 147, I'm just going to add the digits, 1 plus 4 plus 7. And if I add those up, they add up to 12. What's so special about 12? Is 12 divisible by 9? No, but it is divisible by 3. So that's the divisibility rule for 3, right? So I'm just going to take out 3 from here. And you know what I have to do? I have to do some more dividing. Nobody said this was clean. So 3 goes into 147. So that goes in, 4 times. 4 times 3 is 12. Subtract. So 49. So 49 is a non-prime number. Hopefully you're able to recognize that that is 7 times 7. So there we have it. This number is big and nasty. It is not nice. So 2,646 can be written as 2 times 3 cubed. 2, 1, 2, 3. 3 times itself 3 times is 3 cubed times 7 squared.